Before a wooden ship can touch the ocean, it begins deep in the forest. Welcome back to Iron Process, where raw materials are pushed to their limits and transformed into engineering masterpieces. Today, we follow the entire journey from massive trees harvested in dangerous conditions to precision-cut timber inside a working sawmill, and finally into handcrafted vessels built to endure the sea. Every cut matters. Every joint carries risk. One mistake, and the entire process can fall apart. Let's begin. Everything begins in the old-growth forests of the Pacific Northwest. Here, Douglas fir, hemlock, and cedar are the dominant species. Their massive trunks are wide enough to build ships, bridges, or even entire towns. Naturally, given such colossal dimensions, harvesting them is never a simple task. The foresters rely on a time-honored technique called springboarding. They drive planks into the tree trunk to create a standing platform nearly 2 m high, just enough to bypass the flared base and twisted grain, which are prone to splitting and pose a high risk of accidents. As the saw blade bites into the timber, every movement unfolds like a precise geometric equation. First is the face cut, consisting of 2 incisions that create an opening angle of 70 degrees to 90 degrees. This dictates the exact direction in which the tree will fall. Next is the back cut on the opposite side. The craftsman meticulously preserves a thin layer of wood, the hinge, acting as a control line to guide the tree's descent. Finally, the wedges are driven in. Small, yet backed by immense experience, they keep the curve open to prevent the saw from binding and provide the final precise adjustment to the fall. Once the giants fall, they are bucked into logs and loaded onto specialized heavy-duty trucks. These vehicles are engineered to withstand colossal stress, with each truck capable of hauling between 25 and 30 tons of timber. Behind the wheel are seasoned veterans of the transport industry. They understand the nuances of every incline and every sharp curve, precisely when to downshift, when to maintain throttle, and how to manage the brakes to keep the massive cargo secure. Leaving the forest behind, our journey continues to the Hull Oaks Lumber Mill. This is the largest and last steam-powered sawmill in the United States, a place where these massive trunks are tamed by the raw power of steam, a capability that modern high-speed sawmills can no longer match. Upon arrival at the mill, the timber undergoes its first critical stage, debarking. While this process may appear straightforward, it is mathematically essential. The seemingly harmless bark can harbor soil, rocks, or grit, debris abrasive enough to devastate a saw blade. In a high-speed operational environment, such a risk doesn't just drive up blade replacement costs. It creates a lethal projectile hazard for workers throughout the facility. Next, the timber advances to the heart of the entire assembly line, the place where the true transformation begins. Within the vast expanse of the mill, the carriage emerges like a mechanical titan. Sliding along its steel rails, it grips the log with heavy iron dogs, thrusting it directly into the path of the razor-sharp saw blade. Naturally, the machinery is nothing without the head sawyer. They are the soul of this operation. With keen eyes and decades of experience, the sawyer reads the timber, analyzing every grain, knot, and twist to visualize the internal structure hidden within. Immediately, a critical decision must be made. The opening face, the very first cut, is the pivotal move to produce the largest and most pristine planks. right call results in a flawless structural beam. A single miscalculation, however, can turn tons of premium wood into scrap. The carriage retracts, the log is flipped, and the cycle repeats. Piece by piece, the log is squared and whittled down, its hidden value finally revealed. After the initial cuts, the planks still bear irregular veiny edges and a raw surface. The edger takes over from here, delicately shearing away the excess to leave behind perfectly straight, razor-sharp lines. Not even the discarded offcuts go to waste. They are pulverized into chips to fuel the paper industry and biomass energy sectors. Next, the lumber advances to the trimmer. This system consists of multiple saw blades spaced exactly 2 feet apart, which drop into action only when needed to shear the wood into standard commercial lengths. Any planks that fail to meet specifications are immediately diverted for reprocessing. This rigorous quality control ensures that not a single defective product ever leaves the assembly line. The arduous path is far from over. To prevent warping and cracking, an automated system categorizes and stacks the planks, inserting small wooden stickers to create critical gaps for air circulation. Following this, the entire stack of lumber is moved into an industrial kiln. This is a sophisticated process where the wood's moisture content is reduced to approximately 10 to 15%. Only once it reaches this stable state can the timber maintain its structural integrity and long-term quality. Finally, after everything, the lumber leaves the kiln and enters the planer mill. Here, high-speed blades shave all four sides simultaneously, yielding a smooth, polished finish and precise dimensions, transforming raw timber into a finished commercial product. Now, the lumber is ready for its new journey, headed to construction sites, furniture workshops, and factories across the United States. And one of those destinations is the Draken Harald Harfager Shipyard in Haugesund, Norway. Their goal: to build the largest Viking longship of the modern era. While the ancient Vikings built ships based on oral tradition, today's engineering team must begin with detailed technical blueprints. However, these drawings are constantly adjusted right on the shipyard floor to adapt to the unique natural characteristics of each oak timber block. The process begins with the keel, which serves as the foundation for the entire structure. From there, the initial molds for the bow and stern gradually take shape. Craftsmen like Ola, Gunnar, and Arild work with extreme care, adjusting every plank angle, every curve, and critical details like the hood ends, the decisive factor in the ship's seaworthiness. Unlike modern vessels, Viking ships are built using the clinker technique, where the planks are overlapped before the internal frames are fitted. This is a distinct approach where the builder does not force the material into a design, but rather lets the material itself dictate the form. Once the initial frame is defined, the planking process begins. Iron nails are driven from the outside, through the overlapping planks. On the inside, a small washer secures the nail head before the excess is clipped and peened over. Each joint requires dozens of hammer strikes, creating the characteristic clink sound, which is also the etymological root of the clinker technique. Eric and his colleagues carefully install the next strake. The plank is naturally bent along the hull, held in place by wooden clamps, before holes are drilled and rivets are set. Every maneuver requires high precision, as even a minor deviation can compromise the watertightness and durability of the entire structure. As the 8th strake is finished and the 9th begins, the hull gradually rises. From scattered planks, a resilient shell is forming, quietly yet full of life. Once the shell is sufficiently stable, the lower frame's floors begin to be installed. Each frame is steam bent and refined to fit snugly against every plank, ensuring a smooth contact surface and even load distribution. If done incorrectly, even a small point of tension could create a weakness when the ship encounters heavy seas. Lars and Stefan focus on the bilge stringers, the primary load-bearing area of the hull. Meanwhile, more strakes are added, raising the gunnels and completing the overall shape. Inside, longitudinal beams called stringers begin to appear, acting as reinforcement to help the hull withstand longitudinal pressure. At the bow, the work becomes more complex. The planks converge at a narrow point, creating the characteristic hood ends. This area requires near absolute precision, as it directly affects wave-cutting ability and durability in rough waters. Simultaneously, Ola prepares the stern post while Arna tests the vertical stanchions. These components must fit perfectly with the hull, stringers, and crossbeams, creating a tightly linked yet flexible network. As the framing system and plank layers become clearly defined, the upper stringers are installed. These beams are not a single solid piece, but are joined from two sections using a scarf joint. This type of joint extends the material while maintaining strength and distributing force evenly along the whole. Once in place, they help absorb and spread pressure from the crossbeams, making the entire structure more stable. The fastening process is slow and precise. Clamps hold the timber tight to the hull before they are secured with wooden pegs, tree nails, and wedges. At the bow, a symbolic task is underway. From oak blocks, specifically roots with complex natural shapes, the craftsman begins to shape the dragon head. Boney uses modern tools for the initial sketch, but the carving process remains entirely manual. The dragon head is not created from a single block, but is assembled from several parts, gradually forming a symbol that is both fierce and majestic. This is more than a decoration. It is the soul of the ship, the entity that will guide it across the ocean. Once the hole is clearly shaped, the center line stringer is installed. This beam is fitted into slots on the crossbeams, running the length of the ship as a balancing axis. It helps distribute force evenly, keeping the hull stable under the impact of waves and cargo loads. Though nearly invisible from the outside, the centerline stringer is the silent element that keeps the entire ship upright in the middle of the ocean. Peter applies tar to a new plank. Over the tar layer, he lays a strand of hemp. This fiber acts as a sealant between the streaks. The planks are then brought together so that they overlap perfectly. At the bow, the longitudinal beams are installed. These beams are linked using mortise and tenon joints, fitting together precisely without the need for excessive metal. Combined, they create a tight bond that makes the bow rigid enough to take a beating, yet maintains the necessary flexibility. John takes charge of crafting the bow stanchions, the area under the most pressure. 6 stanchions extend upward, not only increasing rigidity, but also serving as bits for securing ropes when docking. After more than 20 months of continuous labor, the ship nears completion. The freeboard, the part of the hole above the waterline, is raised to its maximum height, finalizing the ship's ultimate silhouette. About 10 craftsmen, through patience and traditional skill, have come together to recreate a technique that has existed for centuries. It is not just assembly, it is the restoration of a legacy, where every detail bears the mark of precious history. Next, we head to the Jarrett Bay Construction Center, where the Hull 64 project stands as a definitive icon of distinct maritime philosophy. This isn't just about assembling a vessel, it is a conquest of the boundaries of material science and hydrodynamics. The foundation begins with the structural backbone known as the strongback. In an era dominated by automation, Jarrett Bay continues to preserve the cold-molded boat-building tradition unique to the Carolina coast. Structural strength is achieved through the integration of 3 interwoven layers of marine plywood reinforced with high-strength fiberglass. The precision in shaping the frames and forming the hull is critical, determining how the vessel cuts through waves, maintains stability, and endures the harsh conditions of the open ocean. The technical peak of Hull 64 lies in its propulsion system. Establishing the shaft alignment demands absolute accuracy, where the positioning of the propeller, struts, and engine output must reach perfect balance. Clearances and strut angles are tightly controlled using specialized measuring equipment, optimizing water flow dynamics and overall energy efficiency. Beyond mechanical specifications, the project demonstrates advanced logistics management and master-level craftsmanship. From installing the molded tunnel to achieving a mirror-like finish in the final coating, every stage adheres to the most demanding standards in modern shipbuilding. Yet, every advancement is rooted in the foundation, where the art of traditional shipbuilding has been forged through time. At this traditional shipyard, an icon of classic maritime engineering is being revived, the Mayflower 14 feet clinker dinghy. This is not merely the construction of a boat, it is a test of mechanical precision within a purely handcrafted process. The shipwright begins with a lofting process, scaling the blueprints up to a 1-to-1 full-size layout directly on the workshop floor. Every curve of the keel and the hull's lines are calculated with absolute accuracy to erect the system of molds. The keel is securely fixed onto the building berth. Next comes the fabrication of the stem and the transom. The shipwright uses robust blocks of oak, meticulously shaped to create perfect bevels. The joint between the stem and the keel requires expert joinery and specialized marine adhesives, creating a unified structure capable of withstanding immense compressive force from the water. The real challenge begins with the clinker planking process. Each wooden plank is cut into a complex geometric shape so that when bent, it fits snugly against the hull's curvature. The hallmark of the clinker technique is that each subsequent plank overlaps the edge of the previous one by a small margin. The craftsman utilizes dozens of clamps to hold the planks in position before pre-drilling and driving copper nails. Each copper nail is secured by being peened over a rove, creating a durable mechanical bond that still allows the woodroom to breathe as it expands in the water. The real challenge begins with the clinker planking process. Each wooden plank is cut into a complex geometric shape so that when bent, it fits snugly against the hull's curvature. The hallmark of the clinker technique is that each subsequent plank overlaps the edge of the previous one by a small margin. The craftsman utilizes dozens of clamps to hold the planks in position before pre-drilling and driving copper nails. Each copper nail is secured by being peened over a rove, creating a durable mechanical bond that still allows the woodroom to breathe as it expands in the water. Once the outer shell is complete, the boat is lifted from the molds and turned over. At this stage, work on the interior begins. The ribs, made of flexible timber, are softened using hot steam and then bent directly into the hull. They are riveted through the planking to increase lateral rigidity. Following this is the installation of the gunnels and the thwarts, transforming the hollow hull into a sturdy and functional structure. The stage requiring the most patience is surface treatment. Every square inch of wood is sanded from the coarse to fine to eliminate all imperfections. The initial coats of preservative oil penetrate deep into the grain, followed by at least 5 to 7 coats of premium varnish. Between each coat, the boat is lightly sanded again. The result is a mirror-like finish that accentuates the golden glow of the natural wood grain, while creating an absolute protective barrier against UV rays and salt water. The final steps involve installing the mast, the rudder, and polished brass fittings. Each rigging line is threaded through its blocks, and mooring hardware is bolted into strategic positions. The Mayflower 14 feet clinker dinghy now stands as a masterpiece, the culmination of hundreds of hours of labor and dedication. The vessel is more than just a means of transport. It is a living testament to the preservation of traditional maritime skills for future generations. At Fosenfolk High School, Norway, a unique engineering process is underway to challenge the dominance of modern composites, the recreation of wooden boats using traditional Nordic methods. Instead of seeking perfectly straight trunks, they scout for specific sections of stems or roots, with natural curvatures that match the contours of the bow and frames. This technique preserves continuous grain structures, creating mechanical strength that no modern steam bending method can rival. At the sawmill, the rugged logs begin to reveal their stunning grain patterns under the saw blade. Each plank is milled to a meticulously calculated thickness. Back at the woodworking bench, manual craftsmanship takes center stage. With razor-sharp axes and hand planes, the shipwright meticulously shapes the keel and the stem post. Precision at this stage is measured by the artisan's touch and traditional bevel gauges, ensuring the vessel's foundation is perfectly symmetrical. This is the soul of northern shipbuilding. Rather than joining edges flush, the planks are overlapped like fish scales in the clinker style. Every joint is manually pre-drilled, followed by the insertion of iron or copper nails. This stage requires absolute coordination between two people, one driving the nail from the outside, and another using a hand dolly to peen the washer, rove, tight on the inside. Thousands of rhythmic hammer strikes do more than just join wood. They create a whole structure that is both watertight and exceptionally resilient against the pressure of massive waves. Once the outer shell has taken shape, the team begins installing the internal framing system. Oak knees are carved to fit the hull's curvature with zero tolerance. They are secured with traditional wooden trunnels, tree nails, allowing for even load distribution along the hull. Next, the oars, thwarts, and mast are handcrafted from timber that is lightweight yet flexible. Every square inch of wood is sanded smooth and coated with linseed oil, making the vessel glow with a golden hue under the sun. The big day has arrived. Without the need for heavy machinery, the collective power of the team pushes the boat along wooden rollers toward the water's edge. As the hull touches the cool current, it officially becomes a living entity. The white sail is hoisted, and the boat glides gracefully yet sturdily across the fjord. This is more than a technical achievement. It is a brilliant continuation of a legendary maritime civilization through the hands of the next generation. And so, we have reached the end of a long road, a journey that began in the majestic depths of primeval forests and concludes upon the vast ocean, where vessels imbued with the soul of timber begin their new life. This is not merely the story of a material, it is a journey of transformation. From colossal trees reaching toward the sky to precise cuts and meticulous processing, wood is reborn through human hands and intellect. Every step demands a fusion of experience, technical prowess, and a profound understanding of nature. In the forest, we learn to select and harvest with deliberate care. At the sawmill, raw logs are converted into high-value timber with near absolute precision. And as we step into the shipyard, wood is no longer just a raw material. It becomes part of a living entity, where every curve and every joint carries both structural significance and aesthetic value. What makes this extraordinary is that despite centuries of technological advancement, the core of this journey remains unchanged: respect for the material. The craftsman does not impose, he listens. He does not force, he adapts. It is this philosophy that creates vessels that are not only technically durable, but also in perfect harmony with the laws of nature. Parallel to this is the continuity of knowledge. Ancient techniques like clinker planking, mortise and tenon joinery, and natural grain bending have not disappeared. They endure and evolve, woven even into the most modern projects. They stand as proof that some values are timeless, values that cannot be replaced by machines or technology alone. Ultimately, this journey creates more than just a product. It creates meaning. It connects humanity with nature, bridges the past with the present, and opens a future built on the foundation of understanding and respect. As these ships leave the harbor, they carry more than just cargo or passengers. They carry the story of an entire process, a tale of patience, elite craftsmanship, and the relentless creative spirit of mankind. Thank you for staying with us until the end of the story. If you enjoyed videos like this, please hit like, share, and subscribe to the channel so you don't miss our upcoming features. This is Iron Process. Thank you, and we'll see you in the next journey.